Hello everyone, my name is Shuaibu and I'm an intern at Sparks Foundation, and my project is score prediction using regression model. So basically, all what this project is all about is predicting student score based on the number of hours they study. So let's go forward, and before going further, if you want to have an access to data sets, maybe probably you want to do your own project or one or two, here is the data source. So first thing first, what we did was importing all necessary libraries, which are pandas, numpy, matplotlib, cron, plotlib, and plotlibline, and df. So next thing, what we did is we load the dataset, which is the the web, from the sites, and I read it, and here are the first five columns. And basically, um the data set is of two columns, hours and score. So let's move further to exploratory data analysis. So basically, what this library is all about is it's um kind of it's kind of so this library, this DABL, simply means data analysis baseline library, and what it simply does is it helps in terms of data cleaning, and it also predicts, tells you what types of model your um model is likely to be, based on the target based on your target variable. So I ran it, and here is the distribution of score. It's simply not a normal distribution, and you can see that most students, it occurs that most students um got a score range of 20 to 40. And then here is the linear plot between score and hour, and you can see it's a linear regression plot. It's a highly correlated plot. So we went further to do some EDAs, and as you can see, based on our columns, they are of float and int type. We describe them, and we can see that data set is of 24 rows. The mean hour is 5 hours, and the mean score is 51.48, and the standard deviation of hours is 2.525, and the standard deviation of score is, that's the widespread, is 25.28. The minimum hour a student has studied is 1.1 hour, and the minimum score, that's the smallest score a student got, is 17, and the 25th percentile is 2.7, that's of hours, 2.7 hours, and that of score is 30, while the 50th percentile of hour is 4.88, and the 50th percentile of score is 47. The 75th percentile of hour is 7.40, and that of score is 75.0, while the maximum hours a student took to study was 9.2 hours, while he got 95, while the maximum score a student got is 95%. So based on provided data set, this is a quick summary which consists of 25 observations. We can extract some key statistics. This is a brief summary of what we got from this summary. So we'll move on and to check for null entries, and there are no null values. So since there are no null values, we are safe to create new features. So we create the target and the other set, that's x and y, and which our target variable is hour. So we had to reshape our target variable, that's using the reshape, then passing -1 and 1 into it because of the scikit-learn library that we'll be using. Basically scikit-learn deals with shape, how your data is arranged, and mostly it takes um 2D arrays. So here, this first one that we did before reshaping it, it's in 1D. So um scikit-learn won't take it. So this one we specify its rows and column by doing this reshape, which is 2 by 1 dataset. So here we display the shape. I print out the shapes. As you can see, this one is 25 rows and 1 column, and this one is only made of 25 rows. So here is basically all the sklearn libraries that I need, and from the sklearn model selection I imported trend test splits. From the sklearn linear model I import linear regression, I import absolute mean, absolute error, mean squared error, and so forth and so forth, and I imported cross validation score and k-fold just to check the performance of my model. So I went further to train and test, to split the dataset into training dataset and test dataset, and um, I I we set the random state into 42 so that when we rerun our model, it won't be giving us some random values, it will be fixed. Yeah, so here I instantiate and I predict my score, and here is what we got out of the test. Since it's 20% of the data set, so it took 1, 2, 3, 4, 5. So here are the scores that we get based on the prediction. It's 3, 27, 27, 29, 69, and 59. Then again, it's just a generic thing. I can remove this so we can go further. So here, what I basically do is create a chart and draw a regression line in between to see my model, and here, as you can see, is perfectly fit. This is a very strong positive correlation model. It has a strong correlation, and I went on to fact check, like to compare between the actual score and the predicted score. As you can see, the first one, the actual score is 81. My model predicted that the student will get 83. The second one is 30. And it predicted that the student will have 27, 21, 27, 76, 69, 62, and 59, which is actually looking very good. So based on the information, we can evaluate the performance of the model in predicting the scores. Yeah, so this one is just a brief summary of what how the performance of the model is, and overall based on this limited sample, it appears that the model is relatively effective in predicting scores. Yeah, so here we went further to, since according to the project we were asked to predict the score a student will have if he studied for 9.25 hours, and here it is past the 9.24 hours, and I asked the model to predict, and it predicted that a student will get 92.39% score. Here is it. Approximately the model predicted that a student who studied for 9.25 hours will have an approximate score of 92.4. So here I evaluate the model performance. First thing is using cross validation, and cross validation is a vital approach to evaluating a model. It maximizes the amount of data that is available to the model, as the model is not only trained but also tested on all the available data. So here I created a new feature, k-fold, and I split it into 6-fold, and I shuffle it, and I pass the random state to 5, and I create another feature seed, and which is cross validation score. This is what this basically means. And I passed the key full that I created earlier, and I passed the regression, which is this one, the linear regression, the model that we created. Yeah, so basically, and we checked for the average score and the standard deviation of the score, and here is what I got. The cross validation score is zero. The score of the model is 90%, 94%, 75%, 93%, 95%, and 93%. So the average score is 90. The standard deviation is approximately 69. The model achieved an average score of yeah. So this indicates that the model explains the variation in the target variable reasonably well. Yeah, it makes sense. So here I will decide to check it using other models. The mean square error, the mean square error, the mean absolute error, and the R2 score, which is everything I did. And here are the score: mean absolute error, mean square error, R squared, root mean square. Based on the output, we can draw the following observation: mean absolute error of value 3.92. This metric represents the average absolute difference between the predicted value and the actual values. A lower MAE indicates a better model in terms of accuracy, and you can see this score of 3.9 is very low, which indicates that the model is doing well. MSE of value 18.94 is it measures the average square difference between the predicted value and the actual value. It gives more weight to the larger errors compared to MAE. Similar to MAE, a lower MSE value indicates better model. As you can see, it's also very low. The R square of value 0.96, it provides an indication of how well the model fits the observation. It represents the proportion of the variation in the dependent variable that it's predictable from the independent variable. A higher R score value close to 1 indicates that the model explains a large portion of the variance in the data, suggesting a good fit here. So you can see it's very close to 1, which is 90, which is approximately 97%, 97, 0.97, which is very close to 1. The root mean square of 4.35, it measures the root mean square and represents the standard deviation of the residuals. It provides more interpretable measures of the average predictor error, and so forth and so forth, as you can read further. So this is basically the conclusion, and it says overall the model performance appears to be quite promising. Yeah, as you can see, everything was perfectly well. Okay, the low values of MAE, MSE, and RMSE indicates that the model's predictions are relatively close to the actual values, and additionally, the higher R-square value suggests that the significant portion of the variance in the dependent variable is captured by the model. However, it is important to compare this metrics with context of the problem and other methods to fully assess the performance. Yeah, so basically that's what it all means, because I don't think I'll measure it using another metrics, because these ones are fully okay. So you can see that the model has done really well. And here I come to the end of my presentation. I wish you a very nice day. Bye bye.